What's up guys, welcome back to Sherman the Prodigy. In this video, I'll be talking about the problem with under and overfitting. Let's get started. So first, I'm going to talk about the problem with overfitting. So what is overfitting? Overfitting is when your model learns a little too much from your dataset. So what do I mean by this? I mean that it understands every single data point very precisely and accurately. This, I know some of you will be like, isn't that a good thing? Well, it's often a bad thing, since then if you will apply that to the testing data set that you splitted, then your model will do incredibly poorly, guys. You don't want this, right? That's why there are lots of solutions to overfitting. So let me show you a visualization. This is a visualization of overfitting. So let me get my pointer. So as you guys can see, so there are these curves. They draw it very precisely, right? You don't want this. A good model would look something like this, the black line, right? A bad algorithm is basically the green line. That model, the green line, is just overfitting. It gets the models, or should I say, very precisely. You don't want this, because then in the training in the training data set, it will do very poorly because you haven't seen the testing data set yet, right? So now let me talk about underfitting. So what's the problem with underfitting? Underfitting happens when your data set, not the data set, when your model it's too simple. It can't understand your data set that much. This is a very bad thing. Underfitting is like the exact opposite of overfitting, but in a bad way, right? So you don't want underfitting, because then underfitting is gonna be too bad. You can say it's kind of worse than not understanding the data set at all. It can't handle the data complexity, randomness, and variance. So let me show you guys a visualization. So yeah, so this, okay, so let me get my pointer, right? So this is the model. So the blue line is the model, and this is its true function, right? So the blue one is a bad model. This model underfits the dataset. You don't want this. This model could be like a linear regression, since that's what it does. This is probably another very good algorithm. You want this, right? You want the orange one. You want the true function. You don't want the blue one. It doesn't even understand the dataset that much. So if you get a data point right here, it's not gonna classify. It's probably gonna say 0 or something, since it's not that near to all of these other data points. So if your data point looks kind of like this, kind of curvy and looks all over the place, you need to find another better data, another algorithm. So now let me show you. Okay, so let me press done. Let me show you a good visualization, if you put all of them together. So let me get my pointer, right? So this is underfitting. It doesn't it doesn't understand the data set at all. It looks kind of good, right? I mean, not that good. There's some yellow data point right here, and it got that halfway. You don't want that. This is the overfitting one. It says force fitting. It's too good to be true, because this is a bad thing. Because look, this understands, I told you guys, it understands the data set too well. You don't want this, because let's say that there's a new data point right here, then that would classify this as this one. And since this is too complex, this model is too complex, it understands very almost everything in the training data set, it's gonna do poorly, very bad in the testing data set, because it has zero idea how the testing data set is. This is a good model, since it understands the data set. like in such a good way, right? It classifies the green ones correctly. I mean, classifies the yellow ones correctly. I mean, it got 2 wrong, like it got 2, but but that's fine, right? Because they're like more like right here, then you don't have to worry about these 2 data points. This is a good model. So now I'm going to talk about some ways to avoid over and underfitting. So the first way is KFold Crossvalidation. So I talked about this in like my XG boost video. Like I did KFold Crossvalidation. And the second way is hyperparameter optimization. I already have a video on a hyperparameter optimization technique, grid search. So I'm not gonna focus on hyperparameter optimization in this video. So I'm only gonna work, or should I say, teach you guys KFold Crossvalidation and how it works, right? So I'm gonna talk about KFold Crossvalidation. It's a very good technique. So let me talk about the KFold Crossvalidation a little bit. So what does the KFold Crossvalidation does? So basically, let me get my drawing tool. Basically, so let's say that I have like a grid, for example, right here, right? Okay, this is just a simple grid. This represents the entire data set. What the KFold Crossvalidation does is that it takes a subset of this data set, right? So this could be a subset, right? So, and it inside the subset, it makes like a subset of like training and testing folds. So first it trains them on these training folds. For example, these could be like training folds, like these can be like training folds, and these could be like testing folds. And first it trains them on these training folds that are like randomly selected across the grid, or should I say the entire data set. And then after that it tests them randomly on the testing folds, right? So right, it's jumping. Okay, so this is like a visualization. So as you guys can see, it makes a subset, right? Okay, can I like, okay, great. Yeah, bye grid. Okay, so as you guys can see, makes a subset, right? Makes a subset randomly, and the green ones are the like training data set, and the red ones are probably the testing data set. First trains them on like that part, and then trains on like that, but this is like binary maybe, and then it tests on this, and it takes the entire like rest of the data set and use the rest of the data set for like test training, and then selects randomly selected like, what do you call it, subsets, like this one, that one, and then it like, what do you call it, then it tests it on that. This is a very good way to, what do you call it, to like avoid over and underfitting, which is, so now I'm gonna get into the code. So yeah, let's get into the code. Okay, so as you guys can see, I already have a logistic regression, and the accuracy of that logistic regression model is 89%. So I want to make a quick note that if you like apply the KFold Crossvalidation to your like model, basically your accuracy will be like decreased by some percent. Because I know that some of you will be like shocked here, because it's kind of like weird, but actually in reality it's actually good. It just means that your model with KFold Crossvalidation is much more reliable than like the original, like before you even apply it, the KFold Crossvalidation. So I just want to like make sure that, so the final score after you apply the KFold Crossvalidation is much more reliable, right? So from sklearn .model selection, I'm gonna first import cross val score, and here I'm gonna I'm gonna create a variable called accuracy. I'll set this accuracy to cross val score parentheses. First we're gonna give it a variable called estimator. I'm gonna set this equal to our actual model itself, and then x, right? So we're gonna get a x variable, our independent variable, and I'm gonna give it the train, x train, and then the y. So y, I'm gonna set this, oh my gosh, to train, y train. Great, so that's it. No, not that's it. Let me just do that. Okay, so now I have to like specify one more parameter, which is the amount of folds or that you like want. So the folds, the parameter for folds is CV. So I'm gonna set CV equal to 10 folds, and then I'm just gonna print out the accuracy dot mean, and we're gonna times this average, like accuracy is average, by 100. So we don't get like a decimal value. We want like a float, like. So let me just print out the accuracy, and it's 82%. So as you guys can see, it dropped down like by 7%. Well, that's fine because the model with like the KFold cross-validation, this accuracy is much more reliable. It's much more better, performs much more better than the like actual 89%, like the original one. So I just wanted to like show you guys like this. I know it's like 3 lines of code, and it's like very simple to like perform the KFold cross-validation. It's not like that hard like grid search. And yeah, so that's it for this video. And yeah, see you guys later on the next one.